In today's video, we'll be going through the process of how to complete geometric series with repeating decimals. Well, there are some basic equations that we need to know, which are right here. Well, the first one is the limit as n approaches infinity of s subscript n equals a1 over 1 minus r, and this is how you'd find the value of where the geometric series converges. Then our second basic equation is r equals a2 over a1, and that is to find our r value. Then finally, we have our base geometric series equation, which is just a1 times r to the power of n minus 1. Now let's go ahead and do some practice problem. Well, number one asks us to find the converging value as well as writing the decimals as a series. Well, let's go ahead and do the first step where it says find the converging value. Well, we said that the equation is right here where its limit as n approaches infinity, s subscript n equals a1 over 1 minus r. Well, we know that a1 is going to be this value right here. Well, if you represent this value as itself, it's just going to be 0.8 equals a1, right? So now we need also to find our r value, and our r value is a2 over a1. Well, we found a1, now let's go ahead and find a2. And now to find our second value, we're going to skip over our first value and go to the second value. And we can see that this second value is 0.08. So that's our a2. Now to find r, we do a2 over a1. So we have 0.08 over 0.8, and that gives us a value of 0.1 or 1/10. So now that we know our r value, so r equals 1 over 10, we know a1 equals 0.8. Now let's go ahead and see if we can finish this equation. Well, yes, we can. So we have a1, which you said is 0.8, so 0.8 over 1 minus r, so 1 minus 1/10. Okay, so 1 minus 1/10 is 9 over 10, or 0.9, and we have 0.8. This just simplifies down to 8 over 9, and that is our converging value. Now the second part of our question asks us to write this as a series. Well, to write it as a series, we're going to use our sigma equations. So sigma, in this type of infinitely going on decimals, is going to look something like this, whereas we have sigma, and then on the bottom, we're going to have k equals 1, because we're going to start at our first value. Then our value is going from 1 to infinity, and then we have our geometric equation here. So our geometric equation was in our base equations, and was just a1 times r to the power of n minus 1. So we said our a1 value was 0.8 times r, so 1/10 to the power of n minus 1. So we have here, we're going to be using k instead of n. You can use k, or any type of variable you want. Just make sure you're consistent. So now we have k minus 1, and we have sigma and k equals 1, and 1 to infinity. And this is how you'd represent our decimals as a series. Now let's go ahead and do one more practice problem. And now we need to find our a1 value. And we're going to be answering the same questions we did in number 1, which is finding the converging value, as well as writing the decimal as a series. Well, we can see that we have a continuing value, so it's a bit of a different question. This process is really similar, so let's go ahead and get started. So we need to find our a1 value, then our a2 value, and then our r value. Then we can go ahead and find the converging value. Well, we know a1, so for this type of scenario where we have a constant, and in this scenario, we have a constant of 1.3. It's going to be there regardless. And the part that is infinite is this 8, which is essentially 0.08, and that's our a1 value, because that's the first term that is being infinite. We're going to only focus on those terms which are infinite in the series, as this is an infinite series. Well, we have our a1 value is 0.08. Well, we know the next value is going to be another 8. So this is going to be 0.008. So we have 0.008. That's our a2 value. Remember, at the beginning, we said that a2 over a1 equals r. Let's go ahead and do that down here. So we have 0.008 over 0.08. And again, this will just equal 1/10. And now that we know our r value, which is 1 over 10, so we can write that right here, 1/10. So we know our a1 value, we know our r value. Now let's go ahead and find our converging value. Well, we're going to use our first, and again, we're going to use our first equation, which is a1 over 1 minus r equals our converging value. So let's go ahead and do that. So we have a1 over 1 minus r equals converging value. So we said our a1 value is 0.08, so we have 0.08 over 1 minus r. We said r is 1/10, 1 minus 1/10. And so now we have this. So we have 9 over 10 in our denominator, And in our numerator, we have 0.08. And 9 over 10 just simplifies to 0.9. And our numerator is 0.08. And this fraction of 0.08 over 0.9 just simplifies down to a simple 4 over 45. So this is our converging value right here. And now let's go ahead and express this decimal as a series. And to do that, we're just going to use our sigma equation again, like we did in our last problem. So we have sigma, and then we're going to have k equals 1. And we're going to have 1 to infinity. And this is going to be the same for all these infinite repeating decimals. So now let's go ahead and put our geometric equation right here. Well, we said our geometric equation is a1 times r to the power of n minus 1. a1 is 0.08 times our r value, which we said is 1/10. 1/10 to the power of n minus 1. Well, we're just going to put that right here. So we have 0.08 times 1/10 to the power of n minus 1. Well, now that we have that, we have one more step. And remember, we said that there's a constant right here at 1.3. Since that's a constant, we're just going to simply add it to the beginning of our sigma. So we have plus 1.3. And then that's going to be our final answer for this series. I hope this video helped. If you believe it did, please consider like and subscribe. I'd greatly appreciate it. Check out the Instagram, which is in the description below. If you do have any questions, please list them in the comments or DM me on Instagram. Thank you.